We're recording right now?
We are recording.
Okay, so lecture 11 is what this is, and it's up. I just edited it, so if you have printed this before by chance, there's a few small changes on it. Also under this area, where we're going right now, and we'll continue to do the rest of the semester is, what are some of the big issues with industrial agriculture? Well, rampant, crazy pesticide use, indiscriminate overuse is a huge problem. Okay? It works for agriculture because it's what gave us the kind of production that, one of the things that gave us these very large increases in production over the last 50 years. But it's kind of running out, and it's running out, that window is running out for several different reasons. One of the things is the pests are becoming resistant to this stuff, right? You guys all know how if you take antibiotics for too long, certain bacteria will actually start becoming resistant to it. Same thing with these, right? So when you use these herbicides, and especially the pesticides start becoming resistant. So then we have to start adjusting what kind of pesticides can be used. Second reason that pesticides aren't even very practical the way they're being used right now in agriculture is the government keeps on changing which ones are allowed. Okay, so DDT is an old example of this, but DDT was a pesticide used for mosquitoes and for other things, and we all know that DDT, for example, one of its effects, other than effects on humans, was to make the eggs of birds very fragile. So a brown pelican, which is one of the birds that was really impacted by one of my favorite birds. If you ever been to the beach, my favorite thing is to watch those guys, like 4 or 5 of them in, better than the flying blue angels or whatever, just flying along those waves. And their wingtips, because I'm a kind of wannabe surfer, so the wingtips are literally this far away from the wave, right? The inside guy or girl, so, and it's like, wow, and they come right in front of you. And then that's a good excuse. Then I don't have to catch that wave if it's too big because I was paying attention. All right, anyway, but yes.
I have a mildly off-topic question.
Yes, please.
A friend at AAE told me that you once saw a black rhino.
I have seen a black rhino, and I have been charged by a black rhino. How about that?
What the heck?
Charged?
Yes.
What did you do that led to getting charged?
Well, that's actually not too far off topic, so well done as pulling the instructor off topic. I know you guys are very good at that, but it does apply to this in sustaining. I was working, one of the ways that, of course, the way I was raised in Africa made me very interested in environment, and now obviously environment and its sustainability. But when I was at college, I went and I have an animal science, my first degree is an animal science degree from University of Natal, which is one of our big universities in my home province, which is KwaZulu-Natal. So I got my degree there. When I was there, the Natal Parks Board for our area came and they recruited students to go and do student projects. So it's one of the things, if you ever come to BBC, you'll be involved in. We have students do actual research projects now. We're starting a new wave of them right now. But they recruited us, and we were sent off, well, we went to one of the best national parks in South Africa in KwaZulu-Natal. It's called Umfolozi. And we went there, and the research project was, they used to count the animals, right? So big thing in management conservation now is, man's got in the middle of it, so now we've taken away the range of these animals. They've been put within, in this case, not within fences, but in certain areas, and people live around it, right? So now we have to assess how many animals are there, because now we're actually going to have to manage them, And Americans really struggle with this, but we don't. So, for example, one of the main animals we needed to know the population of was the impala, right? Antelope, about this big, really gorgeous ones, the ones that jump over the road. They're fantastic animals. But they do really well. And so their population was overpopulated, which would cause overgrazing and death of the impala themselves if it's in a bad year. So what they did, the Parks Board did, they said instead of counting these by helicopter, which was super invasive, all the animals, they were counting all the animals, we're going to run a transect. We're going to cut a line through the bush to count these animals, 10 kilometers wide. And we're going to pick our game guards, which were mostly Zulu guys, and we're going to put them with an unsuspecting student. That's how we always do with students. Right? When you get in student research, you give them the really cool jobs, but probably the hard jobs, right? So I hooked up with my guy, and the first morning we headed out, and I speak Zulu, so he started telling me, you know, Numzan, which is I shouldn't expect that high of a respect, but these people are very, very respectful people. He says, Numzan, I don't understand why the Mlungu, which is the white man, is so stupid. I'm like, oh, okay, all right. I mean, he doesn't say it quite like that. He says it much nicer than that. Oh, okay. So what seems to be the problem? Well, he says, everyone knows that if you're going to walk through the savannah, right? So what are we talking about? Grasslands, gorgeous with animals everywhere, and then there's clumps of acacia, thorn trees, right? And the thorn trees are what give most of that area. The grasslands are very productive. I think we've learned about that already, right? In some of the stuff you guys have watched. But these thorn trees are even more productive because they're a legume, like alfalfa. They produce a lot of protein. And black rhino is a browser, an extremely grumpy browser. Probably the most grumpy, aggressive of all African animals, after the hippo, funny enough. They look so cute. And so very aggressive, but he's also very reclusive, and he stays in these little pockets of bush. So some of the pockets of bush might only be as big as this classroom. Others are quite a bit bigger, maybe an acre, and we had to cut through them. So the first one we got to, this guy who was not a chicken by any means, this is his work, right? And he would shoot at poachers and all sorts of things. He literally starts to basically crawl through the bush. I mean, everyone else got back like at noon. We got back right before dark, right? Because we went so slowly, because he was like, if I'm going to do this, if I have to do this, I'm not going to get myself killed by a black rhino. So it went on, and other groups got charged. One of the white rangers said he's not doing it anymore, but of course we didn't have any choice because he's a black guy and I'm a student, so we don't have any real power, right? And so we keep going, and about a week into, we were right in the middle of one of these bushes, and into clumps of bush, and what I remember is the forest just like explodes. You know, there's just, and trees are coming down. And so you're taught, hey, okay, we're going to do this. You look for some likely thorn bush tree, and you climb. Well, they have thorns, every one of them about that long, all the way down the trunk, mostly, right? So I grabbed one that was probably as thick as my finger because I was in such a hurry, right? And I start climbing this thing. I get maybe in the 3 seconds or 4 seconds, I probably get about this high, right? And which would have done me no good, probably made me a better target. But they are very, they have excellent hearing. They don't have a very good, they have a decent sense of smell. They're almost blind. They have very poor eyesight, which makes them, unfortunately now they're being poached worse than anything, especially even in that area. And it turned out the black rhino actually charged across the front. So that's my black rhino sighting and charging story. All right, so should we move on now? Is that suitably impressive?
That was really impressive. I had no idea that black rhino was like hid inside bushes and then
Inside a little mini forest, yeah. Okay. Yeah, and I exploded up the tree. Okay, so what is integrated pest management? We are trying to come up with a solution because spraying pesticides from planes on the people that are around and all the other things that are around, like we've talked about bees, right? So the new class that they're using called nicotinamides, they're nicotine-based things, are very destructive to bees. So one of the causes, is anybody doing colony collapse disorder? Look for, I'm probably not saying it correctly, but nicotinamide, something like that. They're nicotine-based pesticides. And look at the linkages that they have been able to find between them and colony collapse disorder in bees.
I thought it was mites.
There's lots of reasons that they propose. Mites is the most proper. The Varroa mite is probably the main concern, but they like I mentioned when we talked about this, there's several different theories and several different reasons. Okay? All right? It's an IPM now is just like we're talking about sustainability. We're going to now work with the ecosystem. We're not going to come charging in over and above this ecosystem. We're going to work with the ecosystem, you know, just as we do natural cycling and working with the sun as a basic sustainability principle. We're now going to mimic the ecosystem as much as possible to make pest control happen. Because too many pests, we don't have to. So that's a basic thing. We do need to do something. Okay. All right. Okay. So what is integrated pest management? Well, look at the word, integrated pest management. So it's a reliance of a combination of techniques. Again, one more time, not just pesticides. Okay. So one would be biological control. So do you guys know the story of the hare and the tortoise?
Yeah.
Okay, well that's not the one I'm talking about. Do you know the story of the sorry. I'm in a silly mood today. Do you know the story of the ladybug and the aphid?
Yeah.
I've heard of it.
What is it, Enrique?
Oh, ladybugs are predatory to aphids.
Thank you very much.
Oh.
And so
That's
they
awesome.
literally, if you watch one of my favorite shows, Hauser, which I'm sure you guys would never watch, they literally go up into the cirrus and they find these beds of where ladybugs are breeding naturally. They collect them up, they put them in little boxes, and one of the times I was at our local farmer's market, you can buy a little dish of ladybugs. And so people that are silly enough to have roses in the desert, because they're totally inappropriate, in my opinion, you go put your ladybugs out on your roses and hope they eat up all your aphids, because roses have a lot of problems with aphids. Okay, so that's an example of a biological control. Wasps are another really important predator of pests, right? Of insects. We'll find out what a pest is in a moment, right? Pest is just an insect that we don't want because it's damaging something, some part or some process for food production. Cultural controls, right? So even if you guys haven't done agriculture before, you guys know that now we cultivate, we plow. Okay, so cultural controls is mechanical cultivation. We'll see pictures of them. It's literally we plant crops mostly in rows, and then between them, the tractor will drive between the rows or across the rows, and they'll take what's called a harrow. It's a very fine plow. And they'll just plow up the ground between the rows of the crop just to kill the weeds, right? Just to disturb them and kill them. That's a cultural control. There's all kinds of other controls, cultural controls we can learn about. Kind of mechanical methods, right? Habitat manipulation. Okay, so we have one of our students that I'm extremely, I would say, proud of. She works for the Natural Resource Conservation Service. Remember Tony Walters gave you guys that lecture? You should have watched on irrigation for that same organization, the Resource Conservation District, and she designs and implements hedgerows. I talked about this last time with you guys. Around a field, there's a native habitat, which would be manipulating the habitat. So now beneficial insects could be there, and or it's a place where the pest doesn't like to be, right? Because the pest likes corn. So if we have the native habitat, it also doesn't want to be there and can't breed as well, okay? Use of resistant varieties, right? So this would be one of the reasons we actually do GMOs. Some of the GMOs are resistant varieties. That's one of the reasons for having them. Okay, so main thing about integrated pest management is we integrate a whole bunch of different techniques, not just pesticide. We also do a lot of monitoring, and actually, Enrique, I knew there was a connection. What I was doing in that case in South Africa was monitoring animal populations. You have to do the same thing with insects. You actually go out and collect them and measure them and see how many there are, right? And the last part about integrated pest management, basic idea of it is we want to minimize risks to human health. We want to minimize risks to beneficial insects. So bee was also a beneficial insect to the plant because it pollinates. And we also want to minimize non-target organisms, which would be the bees again, as an example, and the environment. We know that these pesticides, if we just use pesticides, are a huge problem getting into our groundwater, for example. Okay? Benefits of using IPM is it relies on these multiple strategies, so you get a little bit of kick out of each one. You're not just sold into the pesticide, and if the pest becomes resistant, you've got a problem if you just have that. I think that's about all. Benefits. Selective use of pesticide, we talked about that. Reduces selection for pesticide resistance. Okay, so it reduces, if you have all these, you're not going to have as much pest resistance to your pesticide. Reduces development of pest resurgence and secondary pest outbreaks, and it's a reliable long-term pest control. Pesticides are kind of a one-time thing. You hit them hard as you can and you just kind of hope for the best. These are long-term methods that will keep rolling over throughout the life of that crop or even into future years. If you've got a hedgerow, native hedgerow planted around your field, it's going to roll into other years, okay? So again, this particular stuff is in many ways sort of beyond this class, but I'm going to point out to you some of the things you need to understand. One thing would be, if you're going to study, and you will have to study this will be quiz 4, what is integrated pest management? You're going to have to be able to write about what that is. So that first slide. This one, the benefits, really important. Why are we even doing it? Okay, so make sure this would be, if you want to make some notes, make sure you study this stuff. Some of the actual mechanical stuff that I'm going to talk about and how we actually do it, it's beyond the scope of this class, actually. Okay, but again, if we're going to do integrated pest management, especially if some of you do, hopefully there's somebody else. I don't remember anyone. Was anyone going to do their report on this? Okay, be a good one to do, by the way, because you got just tell me you got a lot of good stuff to get started. So you're still struggling. Okay. Components of IPM, we've got to identify the pest, we've got to field monitor, we've got to go out there and check what's going on, we've got to assess the population, and then again, we're back to integration. This is the key, integrated pest management, biological, chemical, cultural, mechanical management tools. Okay, so diagnosis of the problem, what does this really look like? We first have to decide what's causing this problem with our crop. Is it a pest? Or actually, could it be frost, hail, or wind? We at the college get a lot of sweet old folks, old guys and older ladies that call me up when I'm particularly busy on my phone, and they say, well, you know, I've got my fig tree is just not doing well. It's got holes in its leaves. And I'm like, well, I have no idea. Because what used to be is there were services for this. The NRCS used to call it agriculture, used to have an extension service. They still do, where people could call and get this. So these folks are used to doing that. So they see the ag department at the college and think that's something we can help them with. But often it could be from frost, it could be from hail, and around here it could be from wind, the actual damage, right? And also they don't realize, which is kind of funny, that they're talking to an animal scientist, and this is like at the edge of my knowledge spectrum, right? So caused by nutrition deficiency, so it could be a lack of iron, a lack of copper, just like it would be in a human. one of the macro or minerals, for example, or micro minerals they need, could be caused by the machinery. You know, the guy driving the tractor, when you go out, you guys are going to love this field trip, by the way. When we go out to harder farms, you're going to drive, you know, you're going to drive in basically the Ferrari of tractors. I'm not kidding you. This thing steers itself. It turns itself. It says good morning. You know, I don't know what else it does. It's crazy. But if that's not properly operated, the damage could have been by the machinery, okay? Or adequate irrigation or inadequate irrigation, right? So a plant that's dying, the leaves are turning brown, could just be it got too much water, got waterlogged, or it got too little water, okay? So first of all, we're trying to, before we go down integrated pest management, let's figure out what's actually going on, okay? Okay, now we've decided it is a pest. Now we have to identify the pest. What is it? There's a lot of different things. Here's, you know, my favorite, stink bug. Makes a stink, but it also causes a problem, right? This is a nematode. Nematodes are little microorganisms, and they cause lots of problems, particularly in things like potatoes. Underground damage, right? So your plant's not looking good above ground, things aren't working well. It could even, the damage and the pest could actually be underground. So it takes a very specialized set of knowledge. And the guy that's going to talk to us out there, and you're going to be watching, so we're going to record this lecture. You need to watch this lecture before you take your quiz. You're also going to have to watch Tim Hayes' video, because he is a pest control advisor and a real expert on this stuff. And he works out in the field. I mean, he'll be on our field trip with us, but he'll also need to watch his video. He gives kind of a history of how this all started and some examples to kind of give you the context, okay? Presence of the pest doesn't mean it caused the damage, okay? So it might not be enough of that pest, or it just might not be the problem in the first place, okay? Not all damage, this is number 3. So this would be a nice question as well, I would say. Why is it important to properly identify the pest? Yes, Enrique?
Do plants have like immune systems to fight against pests?
Yes. Oh, very good question. A lot of what we're doing behind the scenes, and we'll get to this in a moment, when we irrigate properly, not too much, but the right amount of water, and we fertilize properly, especially if we use organic fertilizers that are more balanced, right? Remember we learned that we only use 3 components in synthetic fertilizers, NPK. Then the plant is healthier and its immune system's better. And it will fight off the stuff. So one of the indications, and we'll see this in a moment, that's part of integrated pest management. We have the pest, but was it allowed to get started because there was a what they call a cultural problem, irrigation problem, or a nutrition problem? So, and that goes back to the health of the immune system. Great question. Did that answer?
Yeah.
Cool. Symptoms may be caused by improper cultural practices. Like, you know, the guy pushed the wrong button on the Ferrari tractor and it just ran over a bunch of stuff, right? Or cut it off, right? Okay. Proper identification is essential for choosing the right control actions. Okay. You got to know what it is, and then you've kind of got a series of actions. So, it's an aphid. Well, then I know I've got ladybugs, or I've got a certain kind of wasp. Okay. Great example we have locally that's not agricultural, but it is in our environment, is we have a tree down here in the Mojave River called a salt cedar. It's an invasive tree, it comes from Asia, and it's invaded all the riverine riparian habitats in the Southwest. Well, at the RCD, we have a huge program with Mojave Water Agency to clean that up. And we were going in there and hacking it and spraying it with herbicides, and we'd spent millions of dollars. And as this was going along, a researcher from UC Santa Barbara was developing a tamarisk, this plant's name is tamarisk, beetle. They imported it from Asia. Guess what? There's a beetle that actually eats this nasty stuff. Nothing else will eat it. It's really nasty tasting. So they imported this beetle and they put it in the Colorado River, and now it's made its way all the way up to Barstow. And it's actually controlling the tamarisk without us spending all that money. Big provisor is, we know all over the world we've brought in things like certain kinds of snakes in Australia and Hawaii to control, or ferrets in Hawaii to control rodents and stuff, and then they take off. So you've got to be very careful with this biological control that the biological controller doesn't become the problem. You get what I'm saying? Okay. So, and there's actually a whole line that you could get into, a whole part of the U.S. government that they don't talk about much, called APHIS, APHIS, that does that. They breed these things and study them and make sure that they're not going to become invasive themselves. Okay, so there you go. All the different kinds of things, mites, insects, pathogens, which is the chemical produced maybe by a fungus, weeds, mollusks, which would be snails, nematodes, those tiny little things that are underground, and then even vertebrate. This is my, you know this guy. What is that guy?
That's a squirrel.
A squirrel. This is Neville Slade's arch enemy, after the raven, arch enemy number one. These guys, our ground squirrels, are incredibly aggressive, and they do really well when people are around, and they'll take over whole people's houses. So I live with all the animals out there, but these guys I have to take care of.
Oh, I just remembered you. Okay, I thought that this year was the first time I met you, but I remember you came into AAE and you did a presentation about strapping lasers to the back of
Oh,
tortoises.
no, that's Mr. Huffines' other friend.
Oh, okay, that was the other guy.
Yeah, I know who you're talking about. That's Tim Shields.
Lasers to the back of tortoise.
Thomas.
Yeah, it was the coolest thing ever. He was like, we're gonna have a group and they're gonna have lasers on the back of tortoises, and the tortoises are just gonna shoot the ravens before the ravens land. So there was a time where there's
No, but we have two really serious animal problems up here. Pests, which would be ravens and squirrels.
Sorry for mistaking.
No problem. No problem. I'm honored that I would be that weird that you would. Okay, insects. What are they? How do they look different? A mite looks a bit like a tick. We don't need to get into this, but insects are different. They have certain characteristics to make them an insect, right? But it depends on what they're going to be, what part they're using. Sometimes they're chewing sometimes like aphids, they're actually piercing into the leaf or into the fruit and eating it. Sponging, I don't know what sponging means, maybe living off its neighbors. I don't know what sponging means. Maybe the flies, I think, lick things and pick up the nutrients. I don't know. But excellent. That's enough of that. Pathogens and nematodes. What are some of these pathogens that are a problem? So the pathogen, the chemical, could be produced by a virus. Could be produced by a bacteria or by a fungus, okay? And they'll cause these kinds, it's not the animal itself doing the damage, it's the chemical produced by them doing the damage. And these are some of this is all almond leaf spot, right? And then you identify what the damage looks like, and in this case, you would have to take a sample and send it off to a lab to get it identified. Viruses, as we know, are incredibly hard to identify because they're way more, you don't see viruses on any kind of regular microscope. Okay, ground squirrels again, birds, the raven or the thing. We have, up here we estimate that we have, if we had one raven 50 years ago, we now have up to 10,000. 10,000 times. And this guy is a predator. He'll eat your children, he'll eat your dog. I mean, he steals my eggs every day. And I'm still trying to shoot this guy. Every day he steals my chicken eggs. And that really ticks me off. But anyway, rabbits, voles, gophers, birds, pigeons. You know what they call pigeons in farming?
Sky rats.
Sky rats or flying rats, yeah. They're not cute when there are too many of them. It's all about, again, We're not trying to wipe these things off the face of the earth. It's all about what we started with the story in the Rhino, is balancing these populations. Because when man's in the middle, things like ravens and ground squirrels, like, oh, that's cool. You put your dog food out there every day. Oh, perfect. I'm going to have 100 babies this year. You know, and so you've got to control them. There isn't any choice. Otherwise, they also take over from all the other animals. My favorite little guy is the kangaroo rat. Guys seen a kangaroo rat before? Yeah.
Not in real life,
Aren't
but
they
I've
cool?
seen pictures.
They are the best. And if you're camping out in the desert, they'll come right up to your fire and sit there and look at you. They're so friendly. They have huge eyes, and they sit up on their back. But they're the most gorgeous animal. I'll let you go on your phones for that. Go and pass around a picture. They're pretty cool. Okay, so then it could be weeds, right? And you guys, if you've got lawns or anywhere, Bermuda grass is a grass we grow for food for animals, but it can be very invasive. And then there's all kinds of different kinds of weeds. This one down here is interesting because sometimes we struggle at RCD defining for people what's a weed and not a weed, because the local fire department says, get rid of all your weeds because they're a fire hazard. Well, globe mallow is actually a native plant, and it actually, if you leave it there, it will grow and the tumbleweeds won't grow. So, so sometimes it's a weed, in depending on conditions. Other times it's a plant that you want, right? So all based on whether that plant is inhibiting what else you're trying to do. Okay. All right. Why monitor? Why do we monitor this? Well, I'm just going to stay with the very first one here. Improve the ability to make good pest management decisions. So if we monitor the pest, we know how best to deal with. We know how many of them, and we also know what it is, so that we can deal with it properly. And then we try something, like let's say it's a weed, and we cultivate, we bring that harrow through, and we turn the soil. Then we come back and say, okay, did that take care of the crabgrass? Which would be one of the things you do. And if it doesn't, then we try something else. Okay, field monitoring and population assessment, monitoring again, just talking about it again. I left these slides in because people might want to go into this in more depth, and especially when we teach this class at the college, we've got people that actually want to make a career out of this, right? So we don't want to shortchange the subject too much, okay? So, sampling techniques, this is kind of fun. How do you do it? Well, you can use your eyes, that's a good thing. You can do a beating tray. You literally go under the plant, or the bush, and you just shake the bush and see what bugs fall out. And then you look at them on a microscope or whatever. You can have traps. The one that Tim Hayes will talk about in apples are pheromones, right? Pheromones are the hormones, very small amounts of hormones sent off normally in the air that attract other pests, mostly for mating, right? So you can mimic that, okay? So there's all kinds of ways to do it. Here's a monitoring where we looked at everything within a certain area. So I've got this area. Then I can say, okay, if I've got this many pests in this small area, then just through simple math, I can say, well, then in this 10 acres, I've got X number of this pest. And these guys know, well, if we go over this certain threshold, and we're going to get to that in a moment, go over this certain threshold, we got to do something. Because you've got to realize that these pests are mostly on the lower end of the scale where they multiply very quickly. So you kind of reach a certain threshold, you've got to take care of them, otherwise they're just going to have really bad exponential growth, right? Like we do in humans. They, bacteria multiply every minute or less. So there's the slide, threshold. We monitor. Tim does it on a weekly basis out here in Hinckley on the alfalfa fields. Then it hits that threshold. He's like, okay, all right, we got to do something. We're either going to bring in a beneficial insect, we're going to cultivate, we're going to plow it up, we're going to even use some pesticide. I forgot to mention that, I don't know if you noticed that, but in that original slide, there is limited use of pesticide. Integrated pest management does not mean we never use pesticide again. We just use it as part of the smorgasbord of treatments, right? Okay. So first line of defense.
Stop soon.
Yeah.
Thank you.
Thank you very much. Is prevention, just like anything else. In pollution, it's much cheaper to prevent the thing. So how do we prevent? Well, this would be a good slide to focus in on in terms of testing and being able to get an idea. Tactics, we use pest-free seedlings. So the seedlings we put out there, let's say they're strawberries grown in a greenhouse. They grow them in these little stalks of them. And when they put out, they shouldn't have that pest on them, right? They've been treated. Correct fertilization, that's back to Enrique's question. The cultural irrigation and mowing, so they're kept healthy. Okay, mowing just keeps them from getting too big. So if I mow, let's say around here, a big weed problem is mustard, Sahara mustard. It's kind of pretty, it's got yellow flowers. If I mow it, cut it before it starts to seed, and this is the same in your yards, then I'm going to cut down the seed bank of that. So that's a cultural method. Prevent weeds from reproducing, that's right there. Sanitation of equipment. We had a big workshop this week from Bureau of Land Management, and whenever they collect seed even, they sanitize or clean out seed treatment, the seed collection, so that if there's any weeds in the seed equipment, they get sanitized and treated. Same thing if there was some kind of disease, you'd want to actually sanitize the equipment that you're using. Okay? Look at the long term, we want to preserve biological diversity. So have I really given you an example of how we do that in agriculture? How do we preserve the overall biological diversity? Because I know you've got the cold too. There's several of you are doing something on biological diversity. What's one way I've given you of doing that? We already talked about it a couple of times today. Native hedgerows, right? The total biodiversity, if I've got that around, then there's a chance that I've made a place for that beneficial insect to thrive, right? Away from my crop and come in and help me out, okay? Conserve natural enemies, same sort of idea. If there's a wasp, let's conserve it, let's make habitat for it so they can live. Use resistant varieties, sanitations, and then site selection. Put it in the right kind of place where the pest is least likely. We're going to look at that in the end. Okay, preventing pest problems, plant selection. Now just go into it kind of individual. I don't know what this isn't my presentation, I don't know what he's doing here in the water. I don't know what he's growing there. I think this fellow's got some issues, I'm not sure.
I thought he was mowing the water.
He's mowing the water. It actually looks like it, doesn't it? Oh. Okay, so site selection. We want certain pests, like certain kinds of soil type, slope, water table, proximity to pests. If we know that, a simple example, Farmer Jones over there is awful at what he does, and all he does is spray pesticide. So we know that every year those pests are going to come back and they're going to be super resistant. Well, then we don't probably, let's say Farmer Jones is over here and we're over here across the road. Maybe we don't grow the same crop as him because he's going to have an issue and continue to be sending those little packages of joy our way. Prevailing wind direction, a lot of the stuff, seeds, spores from fungus spread on the wind. Okay, harvest period relative to the source of pests. If you can grow a crop that matures fast enough and you get whatever crop it is off seed or whatever you're doing before the pest really gets going, then cool. So there's lots of art, as it were, and science into making these decisions. So integrating practices, one more time. Biological control, cultural control, mechanical, physical control like plowing, habitat manipulation, use of resistant varieties, and then finally, chemical control, pesticides. Okay, biological control, how do we actually do it? Okay? So biological control is broadly defined as any activity of one species that reduces the adverse effects of another. Okay? All types of pests have natural enemies, and that, remember, what is integrated pest management? We're working with the ecosystem. We're paying attention to the ecosystem and working like the ecosystem would work. They've all got their food web, right? So, so it would be things like plant pathogens and weeds, insects and mites, all have natural enemies. Okay, biopesticides, okay? These are things that are actually made from a biological thing. So this bacteria here, Pseudomonas, is if you grow it and then collect the toxin that it produces, it'll prevent fire blight, which is blight of a leaf. I don't even know what crop that is, okay? And I don't know what antibiosis is, so we won't talk about that. But again, it's the same thing. These biopesticides, you grow the pest that has an effect that will kill another pest, right? And it's mostly because it's a toxin, okay? Disease suppressive compost and soil amendments. Okay, there's certain kinds of compost. Using compost will just, in itself will keep the plant healthy and reduce thing. BT, this is again biological control. This is Bacillus thuringiensis, is a bacteria that will control caterpillars. Okay, so again, we're not going to go into the detail here. Another way to use biological control is competition. You plant something or a plant, your plant you're trying to, is in competition with, let's say, that weed. Or allelopathy. There, got it. I don't do well with these long names. Allelopathy. Do you know what allelopathy is? It happens all in the desert here, very prominent. All around the college here.
The same traits. I don't know, I'm just going off the letters. Allele, path, the same.
What it is, creosote bush. It's all around here. Most prominent shrub all around us here. Sends out in its roots, has some chemicals in its best way to describe it that prevent other plants from growing. Right? So on our place, when you went there, you'll notice when I planted stuff that we planted, they're all natives, but I try to find big patches where there weren't too many creosotes, because the creosotes will prevent that plant. So I planted desert willow, and I planted it in big open areas where there weren't so many creosotes, because from their roots they put out some actual name of the chemicals get eluding me at this moment, but they put out chemicals that prevent that plant from growing. So I can actually look at my willows. I was actually looking at it this morning, and I think about it. And some of my willows are half the size of others, but then I look at them and they're right next to a creosote bush, okay, because it's inhibiting. Okay? All right, biological control with arthropods. Okay, so here's our ladybug, an insect, a little arthropod, and it's eating the aphids. Okay, so there's various ways they do that. Okay, types of natural enemies, real quick. They could be predators. They could be a wasp that actually eats it. They could be a parasite that actually goes and parasitizes that other bug. Or they could actually produce pathogens like that bacillus or that pseudomonas. They produce a pathogen, a chemical that goes and kills it. Okay? All right? Types of predators, all kinds of things. And it's kind of fun in this area because it really is a very kind of fun area. You're dealing with lots of different kinds of bugs. Birds, spiders, lacewings, true bugs, beetles, predaceous flies. Okay, parasites, cultural control. Okay, so now this is one of the 6 or so integrated things we do. Again, we've talked about sanitation, destruction of alternate hosts. We've got a bush or something close to us that is a place that pest likes to hang out. We get rid of it. Habitat modification, that could be the hedgerows. Okay, and crop rotation. Remember we talked about crop rotation as a way to improve our soil? Well, if we rotate the crop, and now all of a sudden those bugs are sitting there hungry in February like, all right, it's time for us to get to work, and the wrong crop shows up. Bad for a bug, right? So, yeah, it's that simple. In irrigation and water management, fertilize it properly, and then some of the other ones we've talked around, soil tillage, mowing, mulches and barriers. So lots of times if you go in the San Joaquin Valley or anywhere else, you'll see they actually put plastic. I actually hate this because it's very environmentally negative, but they put plastic over strawberries. And they actually fumigate underneath that plastic to kill some of the pests. But that's a way, it's basically a barrier from the pests. When you see plastic over plants, that's why it's there mostly. Yeah. All right, avoidance. So we can move on through there. Habitat modification. Okay, so we're gonna alter the habitat of the pest itself. So we could have companion cropping, strip cropping. This is right around rotating the crops. Cover cropping, so once we take our crop off, we put something else on that the pest doesn't like, just in between the growing season. Like we put it on in the winter, waiting for the spring. Okay? Draining standing water for mosquito control. Mosquitoes are the vector how lots of diseases are transmitted, right? We know they transmit malaria, but they also transmit lots of plant diseases as well. Okay? Okay. Cultivation, so now we're getting a look. Now we've kind of gone through all of it, just going to show you guys some photos. So there's it looks like grapes, and there's a guy going down between with a harrow. This piece of equipment is kind of a plow, but it's just gently stirring up the ground. Roots, weeds are very fast growing generally. That's why they're good competitors. And you just need to, they don't have very deep roots. They just stir up the top of the soil generally to take care of it. Okay, barriers. Here's some barriers here. That looks like some plastic barriers here. Here's some more plastic barriers here. Okay, sanitation. Preventing dust. Mummy removal, I'm not sure what that is. Plow down. But anyway, there's sanitation. Chemical control. Now, we're admitting and saying and knowing that we do use pesticides. So this is going to become really interesting when we get to organic farming. Right? So everybody's got this real bee in their bonnet about organic. But did you know that you can be certified as an organic apple grower and still use pesticides? Did you know that? It's true. But you have to use them under very controlled, integrated pest management conditions. So when somebody puts organic on it, especially if it's coming from overseas, you actually have no idea what was used.
This is more in line with biological control. But
Yeah.
did you hear about with the, I think it was cassava, and I can't remember which African country, but then they airdropped wasps from a plane.
Yeah.
Yeah, that was like the coolest thing I had read. I was reading this book called Parasite Rex, and
Yeah.
there were those caterpillars that were eating all the cassava,
Yeah.
and then they just put a bunch of wasps in a plane,
Laying it,
and
drop
then
it.
like flew over,
Yeah.
and then bombed the field with wasps.
So instead of spraying them
Yeah,
with
I don't know.
pesticide, they spray them with wasps. Yeah.
I just thought that was like the coolest.
I haven't
thing.
heard about that, but when you're dealing with big areas, you've got to figure out how to do that on a large scale. So what do you do before you use a chemical? Kind of a cool, important slide. What's that threshold? We don't use that chemical unless we think that pest is going to get under control. Just because it's there, we don't just whip out our tank. We used to do this, by the way. As kids, on the farm, we would be in charge again to make the kids do the nasty stuff. But we had a little hand sprayer, put it on our backs. And you know, if the bottle said 2 ounces, we would put in 4 ounces because we figured, hey, must be better, right? And we didn't wear masks or anything, right? And we just go and spray because you know, as kids, you're thinking, well, if I do double the pesticide, then maybe my dad's not going to make me come back and do it next week. He'll give me a week's break or something. But so anyway, but we got to know that the pest is actually a problem in the first place, okay? And what is the pesticide's efficacy? In other words, how effective is it? And what's the economics? Don't spend so much money on a pesticide if your crop isn't going to balance that. You might want to lose some of your crop if it's not economically viable, right? Can you limit pesticides to certain areas? Select the least toxic chemical. That's where, and I don't know if you know this, guys, but all over the United States, people don't just get to spray pesticides anymore. They have to be super licensed. You actually have to get a permit. Funny enough, you guys should look. Walk into your, you know where you come into your entrance today? And that little hatch where you have to get this thing?
Oh.
Look on the window there, and it says that your whole campus has been sprayed with some weedicide right now, some herbicide from Monsanto. So people that are kind of crazy about this stuff probably went home. I don't know. Did people go home today? But it's right on the window of your thing for everyone to read. They have to post it. You have to get a permit. It's not just something that's done indiscriminately. So, and you'll find out when you visit the farmers, then you get a bit of a perspective of, no, they don't just use this stuff just because they can. Okay. Consider unintended impacts of the pesticide. Could get in the water, it could drift, bees, plants, human exposure. So that's a good slide to look at because now we're relating it back to what's the unsustainable, intensive industrial agricultural approach, spraying too much pesticide. Okay? Integrated pest management, again, that's just a summary of what we do. That's actually a very good one. And it's dynamic. You're continually changing and learning, and we really are at the end. This is just some, if somebody still needs to do an IPM presentation. Is there anybody that is struggling with their topic? There must be some here, Cody. Go for this one, Cody. Okay. You've got all kinds of articles you can find right there, and use this as the basis of your thing. Describe pesticide use as your problem, and then use integrated pest management as your sustainable solution, and you'll be gold.
And then I'll do my resources this week.
Yes, and turn in by Tuesday. Tuesday night. Perfect. And I have graded a few of the quiz 3s. I messed it up, and I miss, guys. This part is really important. I told the rest of the class when it closed, and so some people took it, and so I had to reopen it. So I reopened it this morning till the 20th, and I had to give people 2 attempts. So if you didn't do too well on quiz 3, not because of you guys, but because of the rest of the class, you get to take it again. So pay attention to that over the break. Look at your score for quiz 3. I'll have them all graded at least by tomorrow, and if you need to retake it, okay?
You guys, I wrote you a pass, so if you want to stay for the rest of the lecture, she has passes. Just use that for your teacher.
I am actually done.
Oh, I forget it then.
Thanks, Ron.
Just,
I'm keeping
But I'm happy to answer any questions you guys might have.
sorry.
I can tell you half-true stories about other animal intelligence.
Okay, what you guys want to do? Yeah, she said we don't need a pass.
Yeah, take it, but
You guys still want to? Yeah, sorry. I thought it was going to be a lot longer.
Yeah.
More than you ever wanted to know that you're.
Anything else?
Have a wonderful break, dude. You all deserve it. You too, Mr. Spike. I'm sure you enjoy it. You deserve it the most. You have to put up with all these whippersnappers.
Very good.
This is a great
This
class.
is a good class.
I like
The
this.
other ones.
Yeah.
Thank you. Bye, Soso. Bye.
Except the twin sisters were whining a little bit this morning, but they seem to get over it.
Bye, Mr. Slater.
See you later. Take care. I get fired up by this age of people. or their minds are still open. You know, they don't have the cynicism that develops automatically later in life. I reckon. You know what I'm talking about?
Yeah.
Yeah. All right. But you know what we did find out yesterday, Brian? Don't need to turn that off.
It stopped.
It did stop. Okay, that's why it's flashing. Okay. We're not going to be able to do this as the only mode of operation next year. Apparently, apparently I've only just discovered this as of our meeting yesterday with Mark, Claire, and Melanie, the new dean. I don't know what her last name is.
Oh, the distance.
The instructional dean.
Yeah.
The law requires that they actually have X number of hours that match our hours. So 3-unit class would be 54 hours.
Right.
4-unit class like this, I think it's 72. And the way we're doing it, we're only getting about half of that actually in class. They can't, it doesn't count if it's hybrid. This class part counts, so I think we'll still have a mixture of it and still.
Well,
No, yes,
the only thing I would ask, because the way we were doing classes at Laverne for our master's program, it's a matter of how much time is spent doing work online versus how much is in class. So, if they're saying that you're doing the online, transmitting your presentation is online, that's not true. It's in class.
No, they're counting that as in class.
Okay.
So I think, might be thinking of two slightly different things. One is, like with us,